Hello, welcome to another Research Methods for the Biosciences screencast for SPSS. This screencast covers section 8.3 chi-squared goodness of fit test for one sample. The chi-squared goodness of fit test works on count data and asks if the distribution of counts between three or more categories is what you would have expected. It is obvious, therefore, that we have to inform the program as to what we would expect for the number of cases we would find in each category. We do this by telling the program the proportion of the sample we would expect to fall in each category expressed as a fraction. For example, in column 2 of this table, we see the breakdown of the number of households in Worcester City in terms of the number of dependent children within them. City councils often need such data to plan expenditure for the future, and one of the questions that can be asked is if Worcester is typical of England and Wales in general. Well, the figures from England and Wales are given in column 3, and in column 4 we can express this number as a fraction that gives the proportion of the cases in each group. In column 5 we express this fraction as a decimal. These are our expected proportions. We can now use the proportions given in column 5 to allow the program to calculate expected values, so we can test the hypothesis that there is no difference between the distribution of dependent children in households in Worcester compared to the expected distribution found in England and Wales. I've entered the data into SPSS. In column 1 we have the categories dependent children. I've used a simple number, 0 for no children, 1 for one child, and so on. In column 2 we have the number of cases found for each category. This is how I have set my variables up. You may wish to pause the video at this point. In my dependent children variable, numbers 0, 1, 2 and 3 make a lot of sense to SPSS, but it doesn't make a lot of sense to humans. So I've started to give them some values. If we go up to values and click, we can see I have put 1 equals 1 dependent child, 2 equals 2 dependent children, and 3 to equal 3 or more dependent children. Let's fill in the last value, 0, which will equal no children. So I enter the value 0 into value and no children into the label box and press add. It has now been added to the list. Let's go back to the data view. But I can still see in my dependent children column I've still got the original numbers. I really would like to display the labels. I can do that by tracking up to this button here, which has the forked arrow going to A and 1, and clicking. We now see in the dependent children column my labels are being used. So the data is now ready, except SPSS expects me to put one data point per line. In other words, I would need 27,818 lines, each line indicating the number of children in a single household. Obviously I haven't got time to do that, so I've expressed the data in a tally form where we can see there are 15,787 households with no children. I need to tell SPSS this is what I'm doing. I need to weight cases. You do this by going up to data, down to weight cases, and a window will open. We click the weight cases radio button, and this is the cases variable that we need to select and enter into the frequency variable. This is telling SPSS there are 15,787 households with no children, not just one. I now press OK. So let's do the test. We track up to Analyze. We go down to Nonparametric Tests. A submenu opens. We go down to one sample. A window opens. We could press Run now, and SPSS would have an educated guess of the test we want to run. But that'd be no good for us, because we haven't entered the expected proportions yet. So I'm going to click the Custom Analysis radio button. I'm then going to track up to Fields and click the Field tab. SPSS has already guessed that it's dependent children we want in the test field. If it hadn't, I would have selected it, pressed the arrow to move it into the test fields. I'm now going up to Settings, Custom Tests, click that radio button, and you can see these are the tests it's allowing me to do. I want to use the compared observed probabilities to hypothesized chi-square test. I'm going to tick the box. Now I need to enter the proportions. I do this by clicking the Options button. I then press the radio button Customize Expected Probabilities. We now enter the probabilities in the following table. This is where you can see by using numbers for the category is advantageous. because I can simply put 0 and the relative frequency, which was 0.57. If I had to type the category name no children, it's more complicated, but if I'd made a mistake in spelling, SPSS wouldn't recognise it when it came to do the analysis. I'm now going to put category 1 in, category 2, category 3, and then press OK. I can now run the test. And here is the result. The significance is given as below 0.000. So what is the meaning of the p-value? A p-value of 1 means we can accept the null hypothesis as true, whereas a p-value of 0 means we can accept the null hypothesis as untrue. As we travel from a p-value of 1 to 0, the transition point between true and untrue is set at 0.05 in the biological sciences. But the smaller the p-value, the more confident we can be in rejecting the null hypothesis. And for some experiments, a transition p-value of 0.01 or even 0.001 may be preferable. So a significance below 0.000 means that we can reject the null hypothesis, that there is a significant difference between the distribution of dependent children in the households of Worcester City compared with England and Wales in general. What if you do not know what the expected values of proportions are? Then the default position is to expect the same number of cases in each category. This data taken from table 8.1 shows the number of counts of hollyleaf miners at 3 adjacent height zones on holly trees. There is no prior expectation of what we should find, so in this case we assume that we should find equal numbers in each zone. That is, since we have 3 categories, we would expect a third of the insects to be found in each zone. So let's do a chi-squared test where we do not have to enter any proportion data. This test I'm going to do in a slightly different way, and this will mirror the way we have shown you in the web walkthrough. Please have a look at that document on how the variables have been set up. But you can see for the category information height, I have used 0, 1 and 2, but I have set labels up to make it more clear for us. As before, we've also set the data up as a tally chart and need to instruct SPSS to weight the data. We do that by going to Data, click, down to Weight Cases, up, click the Weight Cases by Radio button, select Cases and enter it into the frequency variable box. So let's do the test. We go up to Analyze and click, down to Nonparametric Tests, down to the Legacy Dialogues in the sub-menu, and down to chi-square and click. A window opens. We now have to tell SPSS the variable we want to use to do the test on. I'm going to click on Height and transfer it to the Test Variable List box using the arrow. The Expected Values box already has the All Categories Equal radio button selected. I now press OK and the output window opens. We can see the asymptote significance is so small that it doesn't even show up in the first 3 decimal places. We can actually work out the exact value by double clicking on the box, moving the arrow away and then hovering over the value. We can see the actual figure is 1.7351 times 10 to the minus 34. We can therefore conclude there is a highly significant difference between the number of hollyleaf miners found at the various zones on the tree. I hope you found this screencast helpful. For further information on how to use this test, or the theory behind it, then please consult the book. More information on how to use the program to perform the test can be found in our online web guides located in the Resource Centre. Thank you for listening.